In this lesson, we're going to look at the idea of congruence of triangles. Now, you probably remember what a triangle is. Here's some examples. It's a three-sided, two-dimensional geometric object. But you may or may not remember what congruence means. Recall that congruent basically means an exact copy of a geometric object. Okay, so if you look at these triangles over here, here we have a triangle, an obtuse triangle, and here's another one that looks exactly like it. Okay, it looks like an exact copy of this one. If that is true, if this triangle is an exact copy of this triangle, then these two triangles would be said to be congruent. Same thing for this triangle and this triangle, and the same for this triangle and this triangle. If they are exact copies of each other, then they are called congruent. Okay? Now, this is what we said previously. Congruent means that the two objects have the same shape. So they're both triangles. You can also say the same object. So like if you had a segment, a line segment, and another line segment, they are the same object. Okay, so that's the first requirement. You can't say that a triangle is congruent to a rectangle. It's not possible because they're not the same object. They're not the same shape. Then the other requirement is that they have to be the exactly the same size, or what we say more technically is the same measure. And that means that all the, basically the distances have to be exactly the same. All the angles have to be exactly the same. Okay? And so if this triangle is congruent to this triangle, then it's going to have all the same measures. So all of the measures, all the angle measures and the side lengths are going to be exactly the same in both of these triangles. But let me go ahead and write out a definition of congruence of triangles. So two triangles are said to be congruent to each other if the longest and middle and shortest sides of the first triangle have equal measures with the longest and middle and shortest sides of the second triangle, and the largest, middle, and smallest angles of the first triangle have equal measures with the longest, middle, and smallest angles of the second triangle. All right, so for example, let's look at this triangle up here. So this looks like the smallest side. This looks like the middle side, and this one looks like the longest side. So now let's look at this triangle. This one looks like the shortest side, this is the middle side, and this is the longest side. If the longest side of this triangle, I'm going to go ahead and put 3 slashes, is equal measure with the length of this longest side, so if the longest side here is the same measure as the longest side here, that means that they're congruent. That means that the longest side here is congruent to the longest side here. And the middle side, I'll put 2 slashes on there. If the middle side on this one is congruent to the middle side on this one, and the middle side on this one, or not the middle, and the smallest side on this one is congruent to the smallest side on this one, okay? And then here we have the largest angle. If this largest angle is the same measure as the largest angle up here, that means that they're congruent. And the middle angle right here is the same measure as the middle angle right here. and the smallest angle right here is the same measure as the smallest angle right here. So all three of these angles are the same measures as all three of these angles, and all three sides are the same measures as all three sides of the other triangle. If that is true, then that is the definition of what it means for these two triangles to be congruent. And so now if this triangle is congruent to this triangle, then its longest side here would be congruent to the longest side over here. It would be the exact same measure. And you can already see that they both have a right angle, and this middle angle here would be the same measure as this middle angle here. Okay? So two triangles are congruent if all of the measures of their sides and all of the measures of their angles are exactly the same. Now this one down here is hard to determine because we can see the shortest side here and here. But this side here and this side here, they look very similar. And it's possible that those two are equal, and that would mean that this is an isosceles triangle. If that's true, then we just call both of the sides the longest side or the shortest side or whatever, okay? So if this side here is congruent to this side, and if this side here is congruent to this side, and all the angles are congruent, this angle and this angle and this angle to this angle, then again, they're congruent triangles. Now note, this angle here does not have to be congruent to this angle. It's just what we call corresponding angles. This angle has to be congruent to an angle over here. And then this angle here has to be congruent to an angle over here. And then this smallest angle here needs to be congruent to this smallest angle over here. Okay? So all you're doing, you're comparing an angle over here to an angle over here with congruence.